Okay, so some specifics around what Rust is as a language. So first of all, it is a strictly typed language. So that means there's a compiler involved. It's not a dynamic or scripted language. You have to compile your source code into object code that can be consumed by the machine. I believe it's an LLVM, so it uses the LLVM backend, if that's interesting. So although it's strictly typed, the compiler is very smart, so it has the ability to infer types. So you don't always have to attribute your variables or functions with the specific types that they take. The compiler is smart enough to be able to infer them some of the time. It's not always true. Sometimes you do have to help the compiler along. It is a non-lazy and imperative language. This means it'll be comfortable to anyone who knows C-like languages, Java or C# or Scala or any of those kind of like mainstream languages, which are imperative, which means that fundamentally it uses like the Turing model for execution on the hardware, which means big words to effectively say it runs one statement at a time. So it will run one statement, update registers, run the next statement, update registers, run the next statement, update registers. So that's pretty common for like most mainstream languages out there. That is different to a language like Haskell, for example, which uses more of a lambda calculus as its execution model, and it's actually a non-imperative language, as well as then, as a side effect, being a lazy language. Rust is also multi-paradigm, which makes it really useful. So that multi-paradigm means you can use it in many different styles. So you can write code in a fairly object-oriented style way. You can write in a pretty procedural type way, which would be more like I write a bunch of functions and I have some data structures, and those functions just work on those data structures, but they do things in a fairly like procedural way, meaning like a stepwise kind of way. And probably the most popular language that is very much a purely procedural language is C. C is a pretty procedural language. You can also, though, use Rust in a fairly functional way as well. It's got pretty nice functional pieces to it. So it has the ability to define higher order functions. It has a way to define sort of lambdas or closures, so to be able to anonymously create functions. It's not quite that powerful, so it doesn't really have a first-class function built in. It kind of emulates it through these traits, but we'll get into that hopefully down the line. But the cool point is that a multi-paradigm language allows you to switch and pick the most suitable style to the problem that you are busy solving, as well as, and within the same code base. You can be fairly object-oriented around certain things. Maybe your access to the database is fairly object-oriented, but maybe your request handlers are quite procedural, and then maybe you've got some sort of calculation stuff or some mathematical stuff that you want to be quite functional around, and you can mix those all quite freely together, which is really nice in Rust. Probably one of its biggest selling points is that it's a systems programming language. And so what this means is it is compiling down to machine code at the end of the day. So it's kind of highly performant. It's a highly performant language. It gives you the ability to take control of memory at the lowest level. So you are in charge of when memory gets allocated onto the heap and when it gets destroyed. Similar to the way you could potentially do that with C and C++ for sure, but I believe with far less headache around managing memory, and we'll talk a little bit more in the next point around the ownership memory model. So in the past, you've really had two kinds of languages out there from a memory perspective. You've had sort of manual memory management, which is like memory is your problem. You allocate it and you destroy it. And when I say you, I mean the programmer. The programmer is in charge of allocating memory and deallocating memory. And that's great because you can write really high performance code in that way. So if you know for certain when something can be freed from memory, go ahead and free it. which means that the machine is being as optimal as it can. The alternate approach, because manual memory management is pretty difficult and it can be a nightmare for people, there is another class of memory management which is called the garbage collector. And this is a very popular one. You probably all have used a language which generates code using a garbage collector to manage memory, and that's where it counts references to memory. And when references, when memory is no longer used, it gets allocated to the garbage collector, and then at some point in time, the garbage collector will run and it'll go and free all the unused memory. And that's awesome because it means that you as a programmer are no longer burdened with trying to figure out when memory should be freed. However, the cost of that and the downside is that you have this other process running inside your program, which is every now and then going to execute and look after your memory for you. So you're kind of giving up a little bit of performance potentially to this sort of other process that runs alongside your program. And in most cases, that's absolutely fine. But in some specific cases where performance or determinism around how fast something executes is very important, that garbage collector can be pretty difficult to deal with. So what Rust has got, and I believe it's probably the first language, I think, it has really invented a third type of memory model, which is something called the ownership memory model. You might also hear people talking about the borrow checker. So the borrow checker is how ownership is checked by the compiler. And what ownership is, it's the compiler is very smartly, while it compiles, it will ensure that memory always has a very distinct owner. And that owner will change over time as the compiler analyzes the flow of your code. It can track ownership of pieces of memory, and it will at the end of that ownership, when that final owner gives up that memory, it will insert a freeing of that object, of that memory at that point. So it's kind of like at the end of the day, you're producing code which looks a lot like handcrafted C, where the programmer is declaring where memory is freed. However, the Rust compiler is writing that piece of code for you based on how it has analyzed your code. And so that doesn't come entirely for free. You still have to. So from a memory perspective, when you're writing the code, you have to be quite explicit about when a function takes ownership of some memory or when it borrows some memory. And I think we'll get into more detail around this. But this is probably the most exciting thing about Rust, as it introduces this third memory model, which is very interesting. It allows you to have this super high-performing code with less of the burden around manual memory management. Not only less of the burden, but also less of the dangers as well. Another really cool thing about Rust is that it's modern, so that means it gets to take the learnings of software development in the last 50 years and produce a state-of-the-art ecosystem, which means that it comes with a package manager called Cargo. It comes with a package registry called crates.io. So that's obviously a website that you can go and search for crates, other people's libraries that they share. You can publish to crates.io. So it's got this nice ecosystem where you can, from the start, you just use Cargo, set up your project, import the libraries that you want, and it all just works really seamlessly. Other nice things about modern languages is they typically have a sane view of what is null. So as we all know, null is this very evil thing that nobody ever needs in their language. And so it's really nice to see languages coming out and dropping support for null. That's awesome. It's got a whole bunch of functional features as well, which is really cool. So it also includes things like nice new modern features like great pattern matching, the ability to pattern match and destructure objects. It also has pretty nice discriminated unions. So these are enums or sum types or algebraic data types or whatever we call them. So the more powerful data structures that you can declare, more powerful than just record. just this ability to hold records. You can also have these enumerations, powerful enumerations. So that's really nice. So some of the sales pitch as to like maybe why you would want to use Rust or learn Rust or pick up Rust to solve your particular problem is you've got this kind of ability to write C-level performing code. Really nice. However, it also has really high safety. So generally you pick C because you want performance, but unfortunately the downside of C is you have the potential to very easily introduce memory bugs, corruptions, leaks, crashes into your program because you have this low-level access to memory. With Rust, you have this lovely ownership memory model, which I think in most cases solves a lot of the downsides of C. Another really great thing is it's got a really nice compiler. So, and the compiler is really friendly. It suggests things to you. It tries to help you write your code as you go. So that's really nice to see. However, it does have an initial high learning curve because it is like a fairly low-level language. There's a little bit more exposed to you. Things like references and the ability to have pointers, etc., are sort of there. So it has a high initial learning curve. But the upside of that is in time, when you want to take advantage of that low-level stuff, you can do it. So it's a language that will, maybe it's initially has quite a high learning floor, but it's also got a really high ceiling, of course, as well. Then, so you can, it's a nice language. It's very flexible. It's got these high-level constructs, a combination of high-level and low-level together. It's got this multi-paradigm thing, which is awesome. And the last very interesting thing is, it's been accepted as the first alternative to C in the Linux kernel. So Linus himself has not even accepted C++ into the Linux kernel, right? C has been the only language that has been good enough for Linus to write modules and extend the Linux kernel with. In the last couple of years, it is starting to look like Rust is becoming more and more accepted as a replacement for C, or certainly a complementary language to C. That is good enough for the Linux kernel. So I think that's a pretty good credibility for Rust being a very nice language. Alrighty.